Hello students, today we start the next lesson number 12, study of sounds. Now main points are given in this lesson: sound waves, velocity of sound, reflection of sound, and the last one, the human ear, audible sound, infrasound and ultrasound. Now first question given here, can you recall first one? How does the velocity of sound depends on its frequency? And second, how is the direction of the oscillation of the particles of the medium related to the direction of propagation of the sound wave? So first of all, I will explain the answers of these two questions given here. Now see on one separate paper. Check here. First one. How does the velocity of sound depends on its frequency? Check that. The velocity of sound is given by V is equal to nu lambda. Where, what are the meanings of these terms? V means nothing but velocity. The symbol nu means nothing but frequency. And this inverted Y, that is a symbol, that symbol is called as a lambda, indicated as a wavelength. Second point, as frequency of sound increases, its velocity also increases. Hence, velocity of sound is directly proportional to its frequency. Remember this concept. Second sub question given here. How is the direction of oscillation of the particles of the medium related to the direction of propagation of the sound wave? Answer. First point, some objects show back and forth movement when a force is applied on them. That is, they oscillate rapidly. This movement of the object is called vibration. All are getting what is meant by vibration? That is the first point given here. Second, sound propagate. Propagate means travel. Sound propagates through a medium. Which medium? That is solid, liquid and gaseous medium. Sound propagates through a medium because of vibrations. And third one, particles of the medium vibrate in the direction of propagation of the sound waves. So this is the answer of that second sub question. Next, come back. Now see here. What are the basic concepts given in the first paragraph? Sound is, see there, I will show the marking. Sound is a form of energy which create the sensation of hearing in our ears. What is sound? Question is asked like this way, 1 mark question. So you mark this first line up to ears. Clear? Starting from a form of energy which create the sensation of hearing in our eyes is called sound. Clear all of you? This energy is in the form of waves. Next, a medium is necessary for the propagation. Propagation means travel of sound waves. Sound waves give rise to a chain of compression. Compression means what? Place of higher density. Means at a less place or more particles are there, more crowd is there. Now see in this figure. This is a compression. And rarefactions. These two new words are here that are related to sound. Compression means place of higher density and rarefaction, that is place of lower density in the medium. The particles, so there are two types of waves. Remember, first one is longitudinal wave and second one is the transverse wave. Definition asked in the exam. Define longitudinal wave, define transverse wave. Now see that. So mark the definition first here. The particles of the medium oscillates about their central or mean position in a direction parallel, remember this word, parallel to the propagation of the wave are called longitudinal waves. All are getting? That bracket is showing here. That is the definition, that is the meaning of longitudinal wave. Second, on the other hand, in the wave created by dropping a stone in a still water. So what we observe? We are observing concentric circles are formed in that still water. All students, I think, familiar about this simple concept. So mark the definition from here. The particles of water oscillates up and down. So mark definition from here. Instead of the word these, what do you write here? The. Clear? So the oscillations are perpendicular to the direction of propagation of wave. We are making little correction here. What is the previous definition given here? Longitudinal wave, the particles of the medium oscillates about their mean position in a direction parallel. What is given here next? The particles, same we are writing here. Starting for the particles of, instead of water, what we write? Medium. The particles of the medium oscillates up and down. That is called as what actually here? Check that. The particles of medium oscillates up and down. That is called as what? That oscillation are perpendicular to the direction of propagation of wave. Anyway, right. So mark the definition from here. The oscillations are perpendicular to the direction of propagation of wave are called transverse wave. Remember this. Clear? Next. Now observe and discuss. A sound wave can be shown in the form of graph. Check these three figures. At any moment during the propagation of sound wave, we would find alternate bands of compression and rarefaction. Observe the figure of the medium. So compression means what? Band of greater density, and rarefaction means what? Bands of lesser density. Check that. R is indicated here. Capital R means nothing but, check that. This capital R means rarefaction. So at this place, their lines are very spread apart from each other, and at the place of compression, check that lines are very close to each other. So bands of greater density means compression, and at rarefaction, what? Bands of lesser density. Clear? See in above figure also, particles are less crowded, so that is a rarefaction, and particles are more crowded, that is a compression. Now figure 12.1a. Where is the figure A shown? This is a figure A. Figure B and figure C is given here. Check that. So 12.1a figure shows the changes in density. Changes in density, less or more, greater or lesser. While figure B shows changes in pressure. In B figure, what is showing here? Check that. Our figure is like this. What is showing here? Change in density. In figure B, what is indicate here? Change in pressure. Clear all of you? Next. So, the changes in density or pressure are shown in the form of graph in figure C. In figure C, both changes are shown. The changes in density or pressure. Here, check that labeled here. What is label given? Check this label. Density or pressure. Here up and down like that. So, this figure C, in that graph, what is shown? The changes in density or pressure. Getting? Next. Now some definitions are given here related to sound waves. First one, the wavelength. The wavelength of sound waves. Check that I will show. Wavelength. The wavelength of sound wave is indicated by the Greek letter lambda, that is indicated as a inverted Y, like this. All are getting? While its frequency is indicated by the letter nu. Nu is like this. Check that. We are writing this letter nu like this. Clear? All of you getting? So that is also Greek symbol used for the showing or denoted as a frequency. Next, define amplitude of a sound wave. So mark the definition from here. Amplitude. Mark the definition from here. The maximum value of pressure or density. The maximum value of pressure or density is called as amplitude, and it is indicated by letter capital A. Next definition, time period of sound wave. Define. Mark the answer from here. The time taken for one oscillation of pressure or density at point in the medium is called time period of the wave, and it is indicated as a capital letter T. All are getting? Yes. The value, next line, the value of frequency determines the pitch. That pitch is high or low of the sound. Very important sentence given here. The value of frequency determines the pitch, high or low of the sound, while the value of the amplitude determines its strength or loudness. Strength or loudness. All are getting? So some part is omitted from these lessons. I will explain. I will telling to you which part is omitted from this page. This last point is given here, research. Clear? This research point is omitted from our syllabus here. This part is omitted. No need to do the study of these two questions. Next. On next page, what is the omitted part? So I will explain here what is that. Now, try this is given here, no? This try this concept is omitted up to the here. So this box is totally omitted from our syllabus. All are getting? So next point we learn here, velocity of sound. Simple question is asked here, define velocity of sound. So what is the answer given here? Mark the answer from here. The distance covered by a point on the wave in unit time, that you write in short. Okay, that box is omitted. I will show the definition. Mark that definition. Start from here. The distance covered by a point on the wave in unit time is called velocity of sound wave. Over. Whatever given in bracket, no need to write that part. Omit that bracket. So distance covered by a point on the wave in unit time. Unit time is fixed time, is called as velocity of the sound. Next, what is the formula of velocity of sound? So velocity, we know the formula of velocity. Velocity means nothing but distance upon time. This is the general formula of velocity. Next is, so at any point on the sound wave covers a distance equal to lambda. Lambda is nothing but the wavelength. Length means nothing but this is the length of wave, that is called as a distance. Clear? So instead of distance, what we write in formula? Wavelength. This length of wave means nothing but distance. So distance, we are changing that word velocity of sound, that yellow color box. Velocity of sound is equal to distance means wavelength upon, instead of time we are writing capital T, that is a time period. So our formula of velocity of sound is equal to wavelength upon time period. Clear all of you? Yes, see that. So wavelength is indicated by the letter lambda and time period is t. But 1 upon t means nothing but the nu. Remember this. That is the relation between time period and frequency. Both are inversely proportional to each other. So instead of 1 upon t, what we substitute here? Instead of 1 upon t, we are substituting the symbol nu. So we are getting one more formula, that is the nu into lambda, that is given here. Check that. So velocity of sound, there are two formulas, wavelength upon time period, that is lambda upon t, or 1 upon t means nu. So that we substitute and we are getting one more formula. Velocity of sound is equal to nu means frequency multiplied by lambda means nothing but wavelength. That is given here. Check that. So velocity of sound is equal to wavelength means lambda multiplied by nu means frequency. Clear all of you? All are getting? Yes. Next. One more. Okay. Next point is given here. In any medium. Check this next paragraph. In any medium, at a fixed physical conditions, the velocity of sound of different frequencies is very nearly the same. Underline the next sentence is important. The velocity is highest in solids and least in gases. Very, very important sentence. This sentence is asked in true or false or anywhere. The velocity is highest in solid. You observe these values in case of solids, and minimum, that is the least in gaseous state. Remember, check that values. Next sentence also important, underline. It increases with an increase in the temperature of the medium. Temperature of the medium increases, the velocity of sound is also increases. Remember this sentence. Next one. So observe this box. This box is omitted, but if you are interested, then read that some lines are given here, but that is the omitted part. For your improving knowledge, you read this box if you are interested. Now check the values. In case of solid, velocity of sound is a maximum in case of aluminium and minimum in which solid? That is a glass. Remember these two. In case of liquid, seawater, in seawater maximum velocity is given, and in methanol, this is also one of the liquid, that is a minimum. Next, in gaseous state, velocity of sound or speed of sound is a maximum in hydrogen, that is 1284 meter per second, and minimum in sulfur dioxide, that is only 213 meter per second. So velocity of sound is a maximum in solid and least in gases. Next. Now here next page, number 130. Only one box is omitted here, that's orange color box. If you are interested, then read this part. Clear? This box is omitted. Little explanation is given here. A peep into the past. What happened? Clear? That is related to our syllabus. You read that lines, but that is omitted. Clear? Improve your knowledge after reading this paragraph. Now check what is given here. Now here 3-mark question is asked on this topic. What is the question? How do physical conditions affect velocity of sound in a gaseous medium? 3 marks question. How do physical conditions affect velocity of sound in a gaseous medium? So 3 points are given here. See that I will explain it. So velocity of sound in a gaseous medium. The velocity of sound in a gaseous medium depends on the physical conditions, that is temperature, density of the gas and its molecular weight. So first one, temperature, that is indicated as a capital T. The velocity of sound is directly proportional to the square root of the temperature of the medium. The velocity of sound is directly proportional to the square root of the temperature of the medium. This means that increasing the temperature 4 times doubles the velocity. So related to this statement, we are writing in mathematical format. Velocity of sound is directly proportional to the square root of the temperature. So we are taking the value of temperature is 4 in square root. So what is the square root of 4? That is the 2. So what we are getting? So V is equal to what we are getting? Answer 2. That's why that is given here. The increasing the temperature 4 times doubles the velocity. All are getting? Now second point, density. Indicated as a symbol. What is that symbol? The symbol is like this. And this symbol is called as a RHO, rho. That is a Greek symbol. By using this symbol, what we are indicate? Density. What is showing here? Now check that. The velocity of sound is inversely proportional to the square root of density. The velocity of sound is inversely proportional to the square root of density. So that mathematical step is showing here. V is equal to, inversely means 1 upon square root of density. Density indicated by the symbol rho. So we are taking the again value 4. So 1 upon in square root 4 at the place of rho. Rho means density. So density increases by 4 times. So what is the answer we are getting? Tell me. 1 upon, what is square root of 4? That is a 2. 1 upon 2 means called as a half. So what we are getting? Value of V is equal to half. All are getting? So now check that this second line what is given here. Increasing the density 4 times decrease or reduces the velocity to half its value. Half means 1 upon 2. We are getting the answer here 1 upon 2. Yes or no? Underline that sentence and remember, increasing the density 4 times reduces the velocity to half its value. All are getting? Same for the third point. This is first temperature, second density, and third one molecular weight, that is indicated as capital M. Same as per the densities. Same as per the density. Check the formula is same. Instead of rho, what we are writing here? That is a M. The velocity of sound is inversely proportional to the square root of molecular weight of the gas. Again we are taking at the place of M, we are taking the value 1 upon root 4. So we are getting the answer 1 upon 2, means increasing the molecular mass or molecular weight 4 times reduces the velocity to half its value. All are getting? So these are the 3 factors affect on the speed of sound in a gaseous medium. This is 3-mark question. So that 3 points you write properly. Next. Now one point is given here, think. Think about it. The molecular weight of oxygen gas, that is O2, is 32, while that of the hydrogen gas is 2. Prove that under the same physical conditions, the velocity of sound in hydrogen is 4 times that in oxygen. Clear? Do the calculation and confirm it. Next sentence you underline. For a fixed temperature, the velocity of sound does not depend on the pressure of the gas. Very important sentence. Mark that. That is asking your true or false question. For a fixed temperature, the velocity of sound does not depend on the pressure of the gas. Next one. Next 3-mark question asked on the topic. Define, what is audible sound, infrasound and ultrasound. The limits of hearing of the sound, human ear. Now check that. The limit of hearing of the human ear are 20 Hz to 20,000 Hz. So that is the human ear can hear sound of frequency in this range. Which range? 20 to 20,000 Hz. These sounds are called audible sound. All are getting? The human ear. Now in this way write the answer. The human ear can hear sound of frequencies. After that cut this word in this range. Instead of that what we write? Sound of frequencies 20 Hz to 20,000 Hz are called audible sounds. Our ears cannot hear sound of frequencies lower than 20 Hz and higher than 20,000 Hz. 20,000 means nothing but 20 kilohertz. 20,000 Hz means 20 kilohertz. Remember these words. So next definition. Sound with frequencies smaller than 20 Hz. Sound with frequencies smaller than 20 Hz is called infrasound. The sound, some examples are given here of where infrasound produced. Underline these examples. The sound produced by a pendulum. Where we observe the pendulum? That is in a wall clock that is moving here and there by a pendulum, and sound generated by the vibration of earth crust just before an earthquake. Have you heard the sound of earthquake? Answer is no. Clear? So that sound generated by the vibrations of the earth crust just before an earthquake. These two examples are given here that are related to infrasound. Next point. What is ultrasound? Okay. Now here, check that. Mark the definition. Sound waves with a frequency greater than, you write 20,000 Hz or 20 kilohertz. Any one number you write here. 20,000 Hz or 20 kilohertz are called ultrasound. Examples are given here. The dog, mouse, bat, dolphin, etc. have a special ability to hear ultrasonic sounds. Remember this, to hear ultrasonic sounds. Thus, they can sense some noise which are inaudible, means not audible to us, not audible to human ear, but these animals hear this ultrasonic sound. Children under 5 years of age and some creatures and insects can hear waves with a frequency up to 25,000 Hz or 25 kilohertz. For example, bats, mice, dolphins, etc. can also produce ultrasound. These animals, bats, mice, dolphin, produce ultrasound. Remember this. Our example in the paragraph here, that is dog, mouse, bat, dolphin. These animals, special ability in them, that is to hear the ultrasonic sound. ultrasonic sound or simply called as a ultrasound. Clear? And here in second last line, bat, mice, dolphin produce ultrasound. So this is a 3-mark question asked in the exam. What is audible sound, infrasound and ultrasound? Clear? This orange color box, if you are interested, see there what is the little story is given, little information is given. So this is our today's topic. Clear? So this is a assignment, today's assignment number video 22, assignment number also 22. What are the questions given here? Define longitudinal wave, define transverse wave. Next, define time period of a sound wave. What is amplitude of a sound wave? What is the relation between question is incomplete, sorry, you complete that. What is the relation between frequency and time period? Frequency and time period of sound wave. Next, what is the velocity of sound wave? Next, write the formula of the velocity of the sound wave. How do physical conditions affect velocity of sound in a gaseous medium? And last question, what is audible sound, infrasound and ultrasound? All are getting? So this is our today's topic. So you listen the video carefully and try to write the answers of our assignment. Thank you.